Okay, so in this video then, I'm going to be going through a few questions based on oxidation and reduction, and specifically oxidation numbers in chemical equations. So at AS level, this is fairly straightforward. Okay, the majority of the time, it's just going to be which element is oxidized, which is reduced, identifying those, and the oxidation number changes, and the oxidation numbers themselves won't be particularly complicated to work out. In addition to that, there may be some stuff on disproportionation, which I will also go through as well. I'll go through a quick question on that. So let's just jump right to it then. So again, you'll be given an equation like this. So hydrochloric acid, manganese oxide, which element is oxidized, which is reduced. So the key part of this really is just looking at the oxidation numbers. Okay, so and remembering the rules that we assign to them. Okay, so really important rules such as oxygen is always -2, unless of course it is bonded to fluorine or part of a peroxide. Now I can't see any fluorine here and I can't see any peroxides, so that means that the oxygen is just going to be -2 here and -2 here. And then you can just start filling them in. So for example, if oxygen is -2 here, then the hydrogens must be +1 each to balance out. So 2 H's both at +1 match the oxygen at -2 and they balance. Nice and straightforward. That also means that in MnO2, if there's 2 oxygens, that takes us to -4. So therefore, manganese must be +4. Okay, now that is fairly self-explanatory, because if oxygen is always -2 and there's 2 of them, that has to be -4. In order to get back to neutral, manganese must be +4. So that gives us a couple of our molecules straight away. We can also work out chlorine as well. Well, chlorine on its own is Cl2, because as hopefully you're aware, all elements are 0 in oxidation state. So there's a few things filled in. The rest of it, again, we can use our rules. Again, we've got hydrogen present here. Now again, hydrogen has a very specific rule. Hydrogen is always +1 unless it is in a metal hydride, in which case it's -1. Now, chlorine's no metal, so that means H here is definitely +1. And Cl is -1. And right there, we've already found our first little change in oxidation state. Chlorine has changed its oxidation state from HCl to Cl2. It's gone from -1 to 0. Okay, now -1 to 0, okay, is the loss of electrons. Okay, which means it's been oxidized. So we've lost electrons here. Okay, so we've lost an electron, so that's oxidation. We'll just put that there for now. The only thing we haven't done is MnCl2. Now again, chlorine is typically -1. Typically -1. And we can assume it maintains that course in this regard. Okay, so in terms of an element, Cl2 is 0. Chlorine here is -1. It's not bonded to multiple elements. It's not in a chlorate. It's not bonded to oxygen, which is when you can get the change in oxidation states. So chlorine is probably -1. And therefore manganese, which can have a variable oxidation state, is going to be +2. And there is the second one. Manganese going from +4 to +2. It's increasing its number. It's being reduced. So to answer the question, we simply put oxidized element is chlorine from -1 to 0, and manganese is going from +4 to +2. Nice and straightforward. There we go. So moving on then, we've got N2O3, unstable oxide of nitrogen, decomposing a redox reaction. It just wants the oxidation number of nitrogen in each one of the compounds. So again, we'll use our rules here. Okay, our rules are hard and fast. Oxygen is always -2, and it will be in this scenario as well. That's really helpful, by the way. And this is going to solve all our problems. So NO is the easiest one. If oxygen is -2, then N is +2. That's straightforward. +2 there. For NO2, it's almost as straightforward. If you've got -2 for oxygen, you've got 2 lots of -2, which gives you -4. So nitrogen is +4. There we go, +4. And N2O3, again, I've got oxygen -2, -2, -2. I've got -6 in total, and I need +6, and I've got 2 nitrogens to do it, so each nitrogen is +3. And there you go, for 1 mark, dead easy. And of course, name the type of redox reaction. We're going from +3 to +2 and +3 to +4 in the same reaction. So we have oxidation and reduction happening in the same reaction. Therefore, it is a disproportionation reaction. And then you've got to spell it. And it's not even about spelling it, it's just such a long word. So disproportionation. Nitrogen is oxidized and reduced simultaneously in the reaction. And again, 2 marks, nice and straightforward. And the final one that I'm going to go through. Iodine, small scale drinking water, reacts with water. Why is this disproportionation? So again, to work this out, we're just going to be looking at the oxidation numbers. So again, nice and straightforward. Iodine starts as 0. Oxygen, of course, we did water earlier. Oxygen's -2, hydrogen's +1. Going on to the other side of the equation, okay, remember oxygen is always -2. I can't see any fluorines present. I can't see any peroxide, so oxygen is -2 here as well. Hydrogen is always +1, so the H here is +1, and the H here is +1. All that remains now is to see what the iodines are. So in HI, if hydrogen is +1, iodine must be -1. And in this little scenario, oxygen's -2, H is +1. So to get back to 0, I need another +1. So what to write down then to get you 3 marks? So explain why it's disproportionation. So very, very easy. Just write down the oxidation. So put iodine. So put iodine. Iodine is oxidized. Okay, so iodine oxidized. Okay, I2. Oops, from I2. Okay, so it's oxidized, it's losing electrons. So I2 to HIO. And the oxidation number change is 0 to +1. Make sure you put the numbers in, by the way. So this is really important. Make sure you say what the species are in the oxidation process. So I2 to HIO is the oxidation step, and it's 0 to +1. Make sure you put the numbers in, and then I is reduced from I2 to HI, and that is 0 to -1. Okay, and then just put iodine. Oops, I don't know what happened there. Iodine is oxidized and reduced in the reaction. Therefore, disproportionation. That's it. That's all you need. You might not even need the last sentence, if I'm being honest. But that's the most complete way to answer it. So make sure you put that iodine is oxidized, what the species are, what the numbers are. Iodine is reduced, what the species are, what the numbers are. If you're, again, you've got to be dead specific, because if you don't include, if you write down, say, for example, 0 to +1 and 0 to -1, and you don't assign the oxidation states, you don't say that is oxidation, that is reduction, you lose marks. So be really, really careful with that, okay? Just be explicit as you can. You don't have to write loads. As I've said, I haven't wrote loads here, in fairness, but just be as specific as possible in your answers. So hopefully that helped with oxidation numbers. Again, in terms of AS level, oxidation numbers don't play a huge role. Okay, there's not a great deal of questions they can ask outside of, what's the oxidation state, what's disproportionation, show how this is disproportionation. However, at a 2 level, it takes on a whole new meaning. So understanding these concepts now is vitally important going forwards into the next year.